So when it comes to multiplying expressions like this, some things we have to pick up on is, first off, if I gave you, say, 12 times 13, you know, we would probably use a calculator for that, but I know that 12 12s is 144. So one more 12, that'd be 156. So 13 12s would be 156. Now, what I can also do is use the calculator, of course, but there is some cool ways of doing this as well. I could write this as 10 plus 2, and I could write this as 10 plus 3. And what I can do is use the distributive property twice to do this math. So what I can do is multiply this 10 through both terms. I can multiply this 2 through both terms. So in other words, if I do those four multiplications, so 10 times 10 is 100, 10 times 3 is 30, 2 times 10 is 50. I'm sorry, got ahead of myself. 2 times 10 is 20, and 2 times 3 is 6. Well, that's going to be 100 plus 50 plus 6. So in other words, that'd be 156. So if we have what's called a binomial times a binomial, we actually have what's called the distributive property in this problem. So that's another way to do this problem. So if we look at our example up here, the square root of 7 plus 2 times the square root of 7 minus 2. Notice that the square root of 7 is irrational and the 2 is rational. They cannot be combined together. The square root of 7 minus 2 cannot be combined together. So what we're stuck with is a binomial times a binomial. So what we can do, though, is we can use the distributive property to do this problem. So kind of like we did over here, we can multiply the square root of 7 through both pieces. Then I can turn around and multiply this 2 through both pieces. If we can do that math, then we're successfully able to do this problem. So the square root of 7 times the square root of 7 kind of looks like this. The square root of 7 times 7 like that, since they're both under the radical. And then I have square root of 7 times a minus 2. So one's outside, one's inside. And then you have a positive 2 times a 7. Notice how one's outside, one's inside. So 2 square root of 7 there. And then we have 2 times a negative 2, which is a minus 4. But notice how there's two 7s inside the radical. That means it comes out as a 7. Notice that negative 2 square root of 7 and 2 square root of 7, that's a zero pair. That just falls out. So all I'm left with is 7 minus 4. So 7 minus 4 actually simplifies down to simply 3. So this problem actually just turns into a 3. Now keep in mind, you could just put this problem into the calculator as well. Since this is a whole number, you could put that in the problem, and it should also give you a whole number, and you could check it that way as well.